How's it going, ladies and gentlemen? Mr. Johnny here again. We're taking a look at Unit 10, Acids and Bases. So the objectives for this unit are we want to be able to describe what an acid and a base is. We want to also be able to identify an acid and base from their formula. We want to be able to look at, all right, well, here's a formula, HCl, is that an acid, is it a base, or is it neither? We also want to be able to describe the properties of an acid and base. What makes an acid an acid? What makes a base a base? How are they different? How are they the same? So let's start with basic question, what is an acid? An acid, by this definition, the Arrhenius definition, which is the first one we're going to take a look at, is anything that gives off an H+, which will create a hydronium ion. We'll talk about hydronium ion in a second. But that's what an acid is. And a base is simply anything that gives off an OH-, which is known as a hydroxide ion. So those are the basic definitions for what an acid is and what a base is. So if we take a look, well, what is this hydronium ion? So we have HCl here, which is an acid, and it is going to give off that H+. So if we take a look, it flies off. We got an H+ in solution. That H+ is attracted to the oxygen in the H2O. So what happens is it will bond to the oxygen, making this ion. Because if we take a look at the charges, we have +1, 2, 3. We got a +3 and we got a -2. So the whole thing is +1. And if we take a look, now this chlorine is just a -1. So we have hydronium being produced by the acid, right? So that's all the hydronium is. It's a H3O+. It's a water with an extra hydrogen. All right, and the hydroxide ion, say here we have lithium hydroxide. It's a base. So what happens when you put it in water is it's going to split the hydroxide off of the lithium, and it's going to produce this OH-. So this right here is the hydroxide ion. And if you take a look, well, the oxygen's -2 and the hydrogen's +1, so we get a -1 for the whole thing. So how can you tell by looking at the formula, is it an acid or is it a base? This is going to use that chem language that you guys have been working on. Generally speaking, they have an H in front of their formula. So if you take a look, well, HCl is hydrochloric acid. HNO2 is nitrous acid. Why are they putting the H first? Because the H is going to pop off as an H+ ion. So that's how they're communicating that this is an acid. There are a couple of exceptions, like for example, this one right here, ethanoic acid, aka acetic acid, can be written one of two ways, right? You can put the H first, like it does down here, or you can put it in with the rest of the stuff. When we get into organic, it'll make more sense why they do that. Same thing with carbonic acid. Basically what happens is when CO2 dissolves in water, it creates this acid. So that's why you could also say CO2AQ, because it's kind of known in the chemistry circles that when CO2 is dissolved in water, it makes this acid. But generally speaking, you look for an H in the front of the formula, and you can also just look on table K, like 99.999% of the acids that we're going to be talking about in class, you just find right off of this table K. All right, well, what about a base? All right, well, a base, there needs to be ionic bonding. So you need to have a metal and some nonmetals, right? You need to have the hydroxide ion. So if you take a look, you got NaOH. Well, how do I know that it's going to give off an OH? Well, because the OH is going to split and separate itself from the metal. So this is just sodium hydroxide. Potassium hydroxide is going to do the same thing. You got this OH there. That's going to split off from the K. Calcium hydroxide, there's two OHs because calcium's +2. Two of them are going to pop off, and you're going to get two hydroxide ions from that. And NH3, all right, is a base, and we'll talk more about that towards the end of the unit. But by this definition, the Arrhenius definition of a base, there needs to be hydroxide being given off. Some properties of acids. Well, you might know this from earlier science classes, but things that have a pH of less than 7 are acids, and things with a pH of more than 7 are bases. You call them acidic or alkaline. Alkaline's for the basic, right? We also know, we may not have put this together, but turns out acids are sour. Dilute acids do not go around tasting, hydrochloric acid for funsies, all right? But if you, just think about the face you make if you bite into a lemon. A lemon's acidic because it's got citric acid, and you bite it and you make this horrible, ugly, sour face, right? So acids taste sour. So Acids will turn litmus red. So if we started with blue litmus and we put it into some acid, it would turn it red. As you can see here, it's redder than it was before you put it in. Another thing about acids is that they also conduct electricity. So here I have a conductivity tester that lights up when you put it in the acid. They also react with carbonates such as baking soda. So this is kind of like the classic volcano experiment where you got baking soda and vinegar. You add them together and it releases CO2. So you can see by the bubbles that there's CO2 being released. You can also make acids by reacting oxides with water. So here I got bromothymol blue in a test tube and some water, and I'm just blowing, exhaling into it, giving CO2 into the water, which reacts with the water and turns the water acidic. As you can see, when the bromothymol blue turns to a greener color, it becomes more acidic, and you can tell by looking at the indicator. All right, so acids summarized. Know that they have pH less than 7. They turn litmus paper red. They taste sour. Oxides react with water to make them. That's why we get acid rain. You know, things like CO2 and NO2 are given off into the air, and then when it rains, that's my raindrop coming down, they react with the gases in the air and become acidic. They conduct electricity, and they will also eat away metals, most metals. Properties of bases. Bases are the opposite of acids in a lot of ways. One being they have pH of greater than 7. So bases have pH greater than 7. They also taste bitter. I've never had the soap treatment because I was a perfect child growing up. But soap tastes bitter. If you don't believe me, lick a bar of soap. I guess don't do that though. It's probably not a good idea. But they taste bitter. All right. Other properties of bases, they turn fat into soap. So if you've ever seen a movie like Fight Club, that's the whole premise of their thing, that they're making soap using fat and base, and the fat they get from an interesting source. But this is why bases are dangerous, right? So we know acids burn your flesh. Bases can be even more dangerous because you get some base on your skin. Well, there's oils and fats in your skin and on your hands and stuff, and the base will slowly turn it into soap and corrode away your flesh, and it won't necessarily burn right away. So it could just be like an hour later, you'd be like, oh wow, there's a huge hole in my hand. Ow. Now it's hurting. What's happening? So be careful. All right. Don't think bases are safe. They're not any safer than acids. So bases will do the opposite than acids. It'll turn red litmus blue. So you can see here I put some litmus paper into ammonium hydroxide at base and it turns blue. Like acids, bases also conduct. So I still got that conductivity tester. I'm going to put it into the base and you'll see the light lights up, indicating that it is conducting electricity. You can see there. Another cool thing about bases is you can make them by adding one of the group 1 or group 2 metals to water. So I added some phenolphthalein so you can see that the color changes when I add this piece of calcium to water. So the calcium gets added to the water, reacts with the water, and it's going to produce hydrogen gas and calcium hydroxide. So you can see the bubbles forming, that's hydrogen gas, and the pink is from the phenolphthalein because the solution is turning basic. Pretty neat stuff. All right, so bases summarized. They have pHs greater than 7, so they turn litmus paper blue. They taste bitter. They conduct electricity. They form when you put any metals from group 1 or group 2 in water, reacts with water to make a base. And they react with fat to make soap, which is pretty neat because soap, I'm a big fan of there being soap.